To solve a problem that has exponents with variables, we're going to have to use logs eventually. With this kind of problem, it's important to recognize that this is very similar to a form that we're used to from previous chapters, but we need special eyes to see it. So let's do a substitution. Let's let y equal 3 to the power of x. Then 3 to the power of 2x is the same thing as y squared. 3 to the power of x is y, and we get y squared minus y minus 6 equals 0. So this is something that we could factor. Looking for two numbers that multiply to 6, so negative 6, and add to negative 1. We get y plus 2 and y minus 3. So we have two solutions. Either y is negative 2 or y is 3. So now we can put back 3 to the power of x instead of y, because they're equivalent. So we know that 3 to the power of x is 2, negative 2, or 3 to the power of x is 3. So to solve this, we can take this, which is an exponential form, and we can change it to logarithmic form. So we'll move the 3 to the other side of the equation by making it the base of a log. So we'll move the 3 to the other side of the equation for the second one by making it the base of the log. Now, log base 3 of 3 is just 1, because 3 to the power of 1 is 3. Log base 3 of negative 2 does not exist, because you can't take the log of a negative number. So we only get one answer, which is 1. To check our work, we'll use a graphing calculator. So let's take a look. We'll graph the left-hand side, and we'll graph the right-hand side, and see if we get x equals 1. So the left-hand side has a complicated exponent, so we need to put that exponent in brackets. 3 to the power of brackets 2x minus 3 to the x minus 6. And for the other graph, we'll graph the right side, which in this case is just the number 0. So when we look at the graph, we get this, and the line 0, which is just the x-axis. So now we can calculate second trace intersection. We go enter, 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 and we should get the crossing point, which is x equals 1. So you can see there's only one answer to this problem.